In this video, we're going to talk about the properties of different materials. We're going to explain what exactly density is. And then we're going to cover the concept of relative density. So, first of all, which of these is not a property of copper? A. High melting point. B. Strong. C. Ductile. Or D. Electrical insulator. The correct answer is D, right? Copper is not an electrical insulator. It is not a property of copper because copper is a conductor of electricity. So that means conductivity is a property of copper, as is ductility. So ductile means you can bend it without it breaking. That's a property of copper. Strength is a property of copper because it's reasonably strong. And another property of copper is that it has a high melting point. Okay, so when you're working as a plumber, you're going to be working with lots of different materials, different metals. So you've got copper pipe, you've got, you work with aluminium sometimes, low carbon steel, several different types of plastics, all of which have their own specific properties. And the reason why it's important to know about these properties is because that's what's going to determine whether you should use copper for a particular job or plastic for a particular job. It comes down to the actual properties. Okay, so these are just some examples we discussed already. So melting point. So if you think about a drain pipe that needs to carry very hot water, you need to know the melting point of the material you're working with, right? It's got to have a high melting point. Okay, then we've got density, strength, corrosion resistance. Let's say you're installing in a factory that uses different chemicals, right? You need to make sure that the materials you use can resist the corrosion that comes from those chemicals. Conductivity is another one, right? If you're using a material that conducts electricity, that could be really dangerous. You're going to have to know that so that you can earth the pipes, right? Or if you want to make sure that there's no risk of electrocution, then you'll use something that is an electrical insulator, and so on. UV sensitivity is another one, so that UV light is what comes from sunlight, right? So let's imagine you've got a material that is sensitive to UV light. The UV can break down certain plastics, right? In that case, you need to make sure that you're only using that in places where it's not exposed to the sun, because if you leave it outside in front of the sunlight, that material is going to get damaged and break down. It doesn't work. So yeah, that's basically why you need to know about properties of different materials. Okay, so here we have some common ones that you've probably heard of in your day-to-day life. So you've got hard, the opposite of which is soft. Some materials are flexible, so they're easy to work with, whereas others are rigid, which means stiff. Then you've got heavy versus light, smooth versus rough, conductive, which we just spoke about, the opposite of which is insulating. Then elastic, which means it can kind of bend and stretch, whereas brittle will break if you try to stretch it. Okay, so that's not an exhaustive list of properties. We maybe come to that in another video. I just want you to understand the idea that every material has its own properties, and it's important to know about these properties because that determines whether you can use it for a specific job or not. Okay, moving on. What is density? A. How shiny a material is. B. How easily a material bends. C. The mass of a material in a certain volume. Or D. How rough a material feels. So the correct answer is C, right? So the two main factors that go into density is mass, right? Remember, we measure mass in kilograms, so it's similar to weight, but not exactly the same. So it's think of it as how heavy a material is given a specific volume. That's very important as well. So it's mass by volume. Actually, the correct formula for density is mass divided by volume, and that will tell you how dense a material is. So, when you think of the word dense, if something's dense in your day-to-day life, you'll think it's thick and usually heavy, and that's correct. Because the more dense something is, the heavier it will be. But actually, it's specifically what determines how dense something is how tightly packed the particles are in a specific material. So high-density objects, high-density materials will be heavy for their size, whereas low-density materials will be lighter. So generally speaking, the more dense something is, the heavier it is. But don't forget, you have to take into account volume. So to give you an example, let's say you're wearing trousers, right? And you've got pockets, one on your left, one on your right. You fill your left pocket with tissues, right? Fill to the brim. And on the right, you also fill your pocket with coins. Right, so remember, the pockets are the same size because it's the same pair of trousers and they're completely full, which means the volume is exactly the same. However, if I ask you which pocket will be heavier, you're going to know that it's the pocket with coins in, because coins are made from metal, and with metal, the particles of metal are much more tightly packed. That's why the pocket full of coins will be heavier than the pocket full of tissues, despite them being the same volume. Okay, so in general, metal is a higher density than woods tend to be, although even within woods and even within metals, you've got different types and different densities. But generally speaking, if you throw a piece of metal into a pond, it will sink, whereas some woods might float. Okay, and this is just a picture to illustrate the point I just made about the pocket. So here you've got two glasses exactly the same size, which means the volume's the same. However, the one on the left is going to be much lighter than the one on the right. Why? Because the coins, which are made from metal, have tightly packed particles, whereas the feathers, the particles are more widely distributed, which means they'll be lighter. So if you hold them in each hand, although they're both the same volume, the one on the right will be much heavier because metal is more dense. So that's the idea of density, right? It's mass by volume. Okay, now we've come on to the idea of relative density. So what is relative density also called? A, absolute weight, B, specific gravity, C, melting point, or D, mass ratio. The correct answer is specific gravity, right? So in plumbing and in science in general, relative density is otherwise expressed as specific gravity, right? So every material has its own specific gravity, and you can look up tables that will give you a specific number for every material to know its specific gravity. Okay, so what does this word relative mean? So whenever you talk about something is relatively good or relatively bad, that means you're comparing it to something else, right? So when we talk about the relative density of any material, we're comparing its density to the density of another substance, right? A standard substance. So matter can be broken down into solids, liquids, and gas. So whenever you're trying to get the relative density or the specific gravity of a solid, metal, plastic, wood, it doesn't matter, or a liquid, water, orange juice, crude oil, right? We always compare solids and liquids to water at 4 degrees, right? If you think about it, the most common liquid on Earth is water, so it makes sense that we should compare all other liquids and solids to the density of water, right? And the same with gases. If you want to know the relative density of a gas, you're comparing it to air, just normal air that we breathe, because air is it's the most common gas on the planet, right? So it's water and air. Comparing the density of any other material to either of these two gives you the relative density. So, question, what is the relative density of water and air? A, both are 2, B, both are 0, C, both are 1, or D, both are 10. The correct answer is C. Right, the relative density of water is 1 and air is 1, because remember these are the benchmarks. So if the relative density of a solid is more than 1, that means it's heavier than water. Right, it was more dense than water, given the same volume, okay? And if it's less than 1, that means it's less dense than water. And the same with gases, right? If a gas has a relative density of more than 1, that means it's it's more dense than air, given that they were the same volume. So, here we go. So water is the standard for measuring the relative density of solids and liquids. That's why it's at 1, right? And the same thing with air. Any gas you're going to compare it against air, which is the benchmark. That's why that's 1, right? So it says use as the baseline for comparing other materials. So, question, which gas is lighter than air? A, butane, B, propane, C, natural gas, or D, none of these? The correct answer is C. Okay, butane and propane, which are used a lot in plumbing. When you come to do your soldering, you're going to be using one of them. They are both heavier than air, which means their relative density or their specific gravity will be greater than 1, right? Whereas natural gas, because it's lighter than air, that means its relative density should be less than 1. It's going to be 0 point something. So here we have it here. So this is a table with some of the most common gases. The first thing to note is that we've got air in the middle, right? And the specific gravity is 1. Why? Because air is the reference for gases. It's the benchmark. You compare everything against gas. So in the previous question, we said natural gas is less dense than air, which means its specific gravity is less than 1, which means it'll be lighter, whereas butane and propane are both heavier than air, which is why they have specific gravities greater than 1. Okay, and it's a good idea to memorize the specific gravities for these two, because that often comes up in the exam. Or you might get a question asking you which is the heaviest, right? Remember, butane is the heaviest one that we use. If you just think of B for base or basement, which is at the bottom, things that are heavy go to the bottom, right? Okay, which solid has the highest relative density? Right, so these are solids now, and remember, solids and liquids, both of them, we measure them against water to get the specific gravity or the relative density. So A, we've got UPVC, which is the plastic, B is brass, C, copper, or D, lead. Right, the correct answer is going to be lead. Right, so remember, relative density isn't exactly the same thing as heaviness, but the heavier something is, the denser it is. So if you know lead is a very heavy metal, which means it's going to have the highest relative density. Okay, relative density of solids. So again, just like we used air as the reference for solids and gases, it's just like we used for gases, we used air as the reference. For solids and liquids, we use water as the reference. So water is always going to be 1. Anything less than 1 means it's less dense than water. So if you throw in polypropylene to a pond, it will float because it's less dense. Whereas the others, including UPVC, which is a plastic, is actually more dense, right? So it's a good idea to remember the relative densities of the most common ones we use. So copper is definitely common. That's 9 times more dense than water. Okay, so to recap on this video, we have material properties determine the suitability, right? So depending on what the job is, you're going to have to know what properties a material needs to be to get the job done, and that will decide whether you use, for example, copper or plastic pipes. Then we've got the idea of relative density, first of all, which is mass by volume, right? The volume bit is very important. Relative density is the comparing the density of a material to a benchmark material, which is either going to be water for solids and liquids or air for gases. And if a material has a specific gravity of less than 1, that means it's lighter or it's less dense than either water or air. And if it's heavier, it's going to have a specific gravity of more than 1.